Hello! This video is for section 4.4 and includes a discussion of the chi-square test of independence. Okay, let's go ahead and get started. So a chi-square test of independence is going to give me a p-value where that p-value is going to help me understand whether or not a relationship exists or an association exists for these tables that we've been looking at. So for example, this first example, we're going to consider the grade 11 students, and we're talking Winona County here, and this is the perceptions of marijuana use. I would like to know that whether or not the pattern that I see for the females, the 12, 12, 18, 17, is statistically different than the pattern that I see for males. So the test that we would be looking at there is whether or not there's an association between gender and their perceptions of marijuana use for grade 11 from Winona County. Okay, the website that I got this data from is here, and you can set up the different menus like I have here in the notes, and you'd be able to do, for example, if you wanted to do a different county. I did Winona, but if you want to do maybe Hennepin County or something, that would be downtown Minneapolis. Okay, you could set that up in a similar way that I've done here. So I don't even remember here. Oops. Substance use and then perceptions of substance use is how I selected the data that I got. So perceptions, and then I was doing that for grade 11, and then you'd have to do this for males. When you do this is for Hennepin County. Take a moment for that to load. Then down here you have the perceptions of marijuana here. So this question right here. So if you wanted to get the data for Hennepin County, which is much larger than Winona County, here's those numbers for, I think I selected males here. So these are the numbers for the males. And then I would have to go back and get the information for females. So that's how you could do this test if you wanted to do some other county. But here I'm looking at Winona County, I'm looking at grade 11, and I want to know whether or not differences exist across genders for these individuals. Here's the H0 and the HA. This is what my table looks like. So again, the heart of my table is this here. So I need a row for the predictor variable, which is either going to be female or male, and then my columns here are my response variable, which is just the marijuana risk there. And again, there's those numbers 12, 12, 18, 17, so those are coming right from that table that I showed up above there. So 12, 12, 18, 17 is for the females, 15, 17, 10, 9 are for the males, so that's going to be in a next row or separate row. I do have totals here because I'm going to need those when I go to compute my expected counts. Okay, so just like when we ran the chi-square test before, I needed, in order to get this done in a spreadsheet, I need the observed counts, which are these here, but then I also need the expected counts. And the expected counts are computed under the assumption of no difference between the males and the females. So how do I get those? Okay, so let's talk a moment about how that is done. So if I don't have to worry about the males and the females, so I'm just going to gray those lines out for a minute, you can see that I had a total of 27 people that thought smoking weed was of no risk. 27 out of the 110. That is 24.5% of the people. So 24.5% of the people of the 110 thought smoking weed is of no risk. Now, how many of those should be women and how many of those should be male? Okay, well, to figure that out, what I need to do is just take the total for the women. There was 59 there. Okay, and just multiply that by the 0.245. And then for the males, I'm going to take the 51. So if I'm looking at female no risk, to get the expected count of 14.48 here, so these are the expected counts down below, to get that expected count of 14.48, what I did is I looked at 27 divided by 110, that's that 24% again, and I multiplied that by 59. For the males, I only had a total of 51 males. So again, about 24% of the males should be in this group here, no risk male. So to get no risk male, again, I take that 27 divided by 110, but I'm multiplying that by 51. That's how I get the 12.52. So that's what number is going there. Let's move over to moderate risk. So for moderate risk, I had a total of 28. So when I ignore gender, I have a total of 28 out of the 110 that thought smoking weed was of moderate risk. That's 25.5%. If there's no difference between the females and males, then I should expect 25.5% of the females to be right here and 25.5% of the males to be in this box that I've selected here. So again, I'm going to take the 28 divided by 110. For the females, I'm going to be multiplying that number by 59. And for the males here, so males moderate risk, I'm going to be multiplying that number by 51. So again, how was the 15.02 obtained in my expected count table? 15.02 was obtained by just taking the 25.5% and multiplying it by 59. I'm going to take that same 25.5% and multiply it by the 51 for the males, and I'm going to end up with 12.98. So I have to do those calculations for all of the cells here to get these expected counts. Once I have that two sets, I have the observed counts and the expected counts, I need to put them into a spreadsheet. So that's what I have here. Let's go to the tab for the males and females. So the 12, 12, 18, 17 here, and then I got the 15, 17, 10, and 9 here. I actually made this table or this sheet much fancier than what I needed. So let me just maybe copy this over onto a new one and kind of just show you what the information that the minimal amount of information that I need. So again, these are going to be the expected counts or observed counts here. 12, 12, 18, 17, 15, 17, 10. Again, those are just coming from the table that I started with. Way up here. 12, 12, 18, 17, 15, 17, 10, 9. Now these are going to be my observed. I also need to compute the expected, and those are the values that I just walked through there and showed you. So that's where I got to do a little bit of math there, or a little bit of calculation there to get those expected counts. Sorry about that. Go back down here to get these expected counts. So I need both of those things in my spreadsheet here. Oops. Now to do the chi-square test, what I need is just to get the p-value here, and this again is for the chi-square test. To get that p-value, I'm just going to type equal chi-test. I take the observed counts, comma, expected counts. Okay, so that's the information that I need to complete the test. And that p-value is provided there, 0.14. Okay, so this is the information that I need to actually run the test in a spreadsheet. Now, I did a lot more fancy things over here when looking at this data. I put the totals in there and I color-coded things, but here's that 0.1461. You don't have to do all that other stuff. I did that, but you don't have to. The point being, we just use the spreadsheet to compute that p-value. Okay, this is all shown here in the notes for you, and the p-value is 0.1461. Is the p-value less than 0.05? It is not. So the data does not support the research question here. So again, writing a conclusion. It's been a long time since we wrote a conclusion. But what I need to do to write a conclusion is just to go back up and get my research question. So let me go ahead and put that here. And I do not have enough support, so I'm going to start my conclusion with there is not enough statistical evidence to say differences exist between genders in the opinions regarding marijuana use for 11th graders from Winona County. And then again, we usually put that p-value in there which was, what was it, 1461, I think? Yep, 1461. So that's a solid conclusion there. It has the three pieces that I need: your decision, what your question was, and then the amount of evidence that you have. So I guess there's not differences in the perception of marijuana use for 11th graders in Winona County. There's not differences across the genders. So these two sets of numbers are too close to one another. Okay, where were they originally here? Those two patterns, the 12, 12, 18, 17 and the 15, 17, 10, 9, are statistically just too close to one another. Here I made a 100% stacked column graph of my observed data. The great risk is here at the top, and the no risk is at the bottom there. And you can see that the trends for the females are pretty similar to the trends for the males. We do have a little bit more women, females, saying that smoking weed's of great risk compared to men. And we also have more males down here that are thinking smoking weed's no risk. But again, these patterns are just too close to one another to say that statistical differences exist. Let's do another one, and this one is going to be whether or not the perceptions of marijuana use changed from 9th grade to 11th grade. So here, for example, 442, what I'm going to do is just look at the 9th grader. I'm not going to worry about gender here. So I'm just going to look at the 9th graders and see how much it changed until they got to 11th grade. Again, this is for Winona County. Because there is going to be, we'll see that there's going to be a statistical change or a significant change there between 9th grade and 11th grade. I don't think we're going to see one between 8th grade and 9th grade. That's just not enough time. Okay, that's only 1 year apart. That we probably are not going to see a shift in 1 year time period. But here, going from 9th grade to 11th grade, we might. So are there differences in the opinions of marijuana use between grade 9 and grade 11? Okay. Again, I need to get the observed counts, and the observed counts, what I'm going to do here is just, I'm not going to worry about gender, like I said, so I'm going to take the 6 and the 16, that's going to be 22, the 13 and the 14, that's going to be 27, 24 here for moderate risk, and then 353 there for great risk. So I'm going to end up with 22, 27, 24, 53. Okay, those are the numbers for my 9th graders, and then I'm going to go get those same set of numbers there for my 11th graders. So there's going to be 27, 29, 28, and 26 there for my 11th graders. So the 27, 29, 28, 26. These are going to be my observed numbers, right? And then again, I need to compute the expected. So let me, looks like here's my expected counts. Again, this is going to be, excuse me, this is going to be a two-step process. So I take the 49 divided by the 236. So let's grab a calculator here and do that. 49 divided by, what was it, 236? Oops, try that again. 49 divided by 236. It's 31%. So when I ignore the grade level here, 31% of the kids think that smoking weed's of no risk. So 31% of the 9th graders should be in this group. So that's where this 26.16 is coming from. Again, that is that 31% of the 126. So just take 0.31 times 126 and you get that number. Likewise, for grade 11, I only have 110 students there, but again, that same percentage, that 31% of the 110 is going to go in this box here. Okay, once I get here's the observed counts. I got to do the expected counts here for all 8 of those cells again. And I've done those here in orange for you. And then I'm going to do my chi-square test just like I did before. The p-value here is 0.0284. This is less than 0.05. So I'm going to say that the data does support the research question for this particular example. So I am going to be able to say, so let's go ahead and go back up and get the conclusion that I wrote before and just modify it slightly. So there is enough statistical evidence this time because it's less than 0.05. To say differences exist between, what do I do? I'm doing grade 9 and grade 11 regarding their opinions of marijuana use. Something like that. And this will be 4 kids in Winona County, I guess, as well. So maybe I should, there is enough statistical evidence to say differences exist between grade 9 and grade 11 Winona County students regarding their opinions of marijuana. And the p-value there, we would report that. Oops. What was the p-value? 0.284. Okay, so we can say that the opinions of marijuana use, or the risk of marijuana, there did change between grade 9 and grade 11. We could do grade 8, 9, and 11 as well. 8, 9, and 11 all together and see. That p-value is probably going to go up a little bit because grade 8 and 9 are pretty similar to one another. If you just compared grade 8 and 9 to one another, you're probably not going to see a difference, like I said. One thing about this test is it's a two-sided test. So the chi-square test of independence is definitely a two-sided test, just like the chi-square test that we looked at earlier. So I am purposely writing these as, are there any differences? Because these are two-sided tests. What we might be interested in is whether or not those opinions have slid down the scale when we get up to grade 11. And actually, the data tends to suggest that as well. If I look at the data here, okay, so look at the grade 9 versus grade 11 no risk. We had more students, right, say no risk for grade 11. Or if we worry about the great risk group, we had quite a few here, about 40% of the kids in grade 9 thought smoking weed was a great risk, but that slid back to about 25% here for the great risk. So are the patterns kind of sliding back here? It looks like the slight risk is pretty much the same, pretty much equal there. Moderate risk maybe is a little bit bigger here for grade 11. What's probably happening here is some of these great risk kids now think it's just a moderate risk, right? So I would anticipate if this box is getting smaller, they're probably sliding into the moderate risk box. But unfortunately, a simple spreadsheet cannot do a trend test for this to see if the patterns have slid back. We do have a test, and that's called the Cochran-Armitage trend test here. And I used a different software package, not a spreadsheet, to compute this, but this p-value right here is suggesting that we do have a trend in this plot, which that makes sense. And that's a one-sided test, right? So that trend test there is a one-sided test. So I can say that in grade 11, the patterns are sliding, the trends are sliding down the scale a little bit. People are less worried about smoking weed in 11th grade than they are in 9th grade. But again, that test is not something that is can be done with a simple spreadsheet, so you're not going to be responsible for this in this particular class. But I guess important thing here, why I mentioned this, is just know that one exists. So later on in the real world, there are one-sided versions of these tests that do exist. All right, here's another example about HIV prevalence in the state of Minnesota. And this is the most recent report that I can get this, where I can get this information broken out by ethnicity. So this is how people get HIV, okay, or get AIDS. For whites, it tends to be MSM, about 76%. And MSN is just men having sex with other men. So this is gay sex here. So for whites, that's most prevalent. How people are going to get HIV or AIDS is through the use, or through gay sex. We also have some drug use here as well. And the heterosexual sex is only 2% for white males. If we look at these others for African American, it's similar. There's less with the MSN/IDU. So that's intravenous drug use there, sharing of needles and such. So somewhat less there for African Americans in that group. Here's Hispanics. Again, Hispanics tend to have a lot of people getting HIV through gay sex. The one that really stands out here is the African born. Okay, notice how much the MSM has slid. Okay, that's the dark blue there. That is really slid back for African born individuals. And the heterosexual sex has gone up a lot. I do have a couple questions here about that, in particular number 5 here. In several African countries, it's against the law to identify as a gay man. And in fact, in some areas, you can actually be sentenced to death for being a homosexual. So maybe that is playing into why African-born males have a very different, or at least are reporting, okay, this is how they supposedly got HIV as they are reported. They might be very afraid to say that they got it through having sex with other men. Or it might be that they're not getting HIV that way. We don't know really which is the case here. But certainly if you are worried about how am I going to communicate to these different populations of people, so what might go on my pamphlet for white males? All right, well, you better be talking about gay sex there. Or for Hispanics, you definitely want to be talking about gay sex. So if you are running a free clinic, let's say for Hispanics, or in a neighborhood that tends to have a lot of Hispanics, your flyer should definitely be talking about gay sex and how dangerous that can be in terms of getting HIV or AIDS. However, when we're creating that same flyer for, say, a Somalian community, okay, Somalia is from Africa, you might not want to emphasize the MSM so much. So we might want or need different pamphlets about how to prevent one from getting HIV or AIDS based on what free community clinic you're putting that pamphlet in. I went ahead and made all of these into a mosaic plot, kind of like what we've been doing in class. I think that's a little bit easier to make comparisons there. So we can definitely see that the heterosex here category for African born is much, much, much higher than all of the others. Or the MSM, which is the gay sex, you can see that that's much reduced for the African born. Gay sex is actually the highest rate for Asian individuals. So there's a few questions here that you can answer. I'll let you answer those. Maybe number 11. Is it unethical to investigate data in this manner where I'm trying to understand the relationship between how people get HIV or AIDS and different race and ethnicities? Some people are going to push back on this and say that we shouldn't be doing these types of things. Okay, I think that taking this stuff into consideration could make us more successful. If we understand the modes of exposure across different races and ethnicities, then maybe we could figure out how to reduce that rate, especially for certain populations like the African-born individuals. So personally, I do not think that we should shy away from doing discussions like we've done here. Okay, the last couple of examples, example 4.4.4, I think I'm going to just hold off on. It's just doing a chi-square test between different occupations and then whether or not an individual's suicide was a violent suicide. And then over here, I have different occupations and why were they admitted into a treatment program, psychosis or drug alcohol. So I will leave this example to you. And then here's another one on Department of Corrections and the sex offender treatment program that we talked about in the at the end of section 4.2, I believe it was. Just another study with some real data about never entered the program, did they quit the program, or did they complete the program? And here are the data values and also the percentages. This is the graph they created. A much better graph, in my opinion, would be one of those 100% stacked column graphs. So again, I'll leave this one up to you. I might make one of these the quiz for section 4.4. Okay, that does it then for the chi-square test of independence of section 4.4. Thank you and have a good night. Bye-bye.